Let's look at the linear activation function. This is a function can be used as a pass function. So what we have on the slide are the input values x that go from -10 to +10, and these are the input to the neuron A, which uses the linear activation function in this time. And what this function does is shown in the green box on the top right, which essentially returns all the values as is, which we see in the output column A. On the right hand side, we see the plot, which is the blue line. That is the linear activation function. It's a straight line because we are plotting the same input values against the output values, which are identical, and so that's a straight line. The magenta dots are the values that we have in the column on the left hand side on A. Let's look at how we can use this function in TensorFlow. So here in TensorFlow, we'll create the tan we'll create the linear activation function. So this is the linear, and this simply takes in the value x. That's the output is going to be the x as is. So linear, and we'll create the values of x. tf.lin space will grow from -10 to +10, and we'll create a set of 100 values, and y is going to be our activation. tf.keras.activations.linear takes in the value of x, and we can plot this plt.plot x comma y, plt.grid, plt.show, and it should be a straight line. It's a straight line that we just saw, so it's a pretty good straight line. And we can also calculate the values of y. Essentially that's going to be the same as x, and we can print those values as well. It's going to be the same thing that we have. So it's going to be overlay on top of that line. That's the blue line. We now see the new orange line. And as compared to the other plots, maybe let's just out of interest, this is the last activation in this discussion. So why not create a plot for the other values that we have and put an overlay so that we can see all of these values together. So let's get started. I'm going to call this instead of y, we'll just label this as ELU, and this is going to be SELU. Then we have the GELU, and after GELU we have the I think it's a swish, SWISH, and then we have the mish, and after mish, of course, the relu. We have the sigmoid. So some of these values are not going to show up, so we'll plot only those that will show up. So we have the sigmoid, and then we have the softsign, softplus. Let's put these down here. We have the softsign, then we have the softplus, linear sigmoid. Am I forgetting anything? Yep, there is one more. We have the hard sigmoid. I think that should do it. So let's copy, and here we'll create the label. Label is equal to, this is the linear activation. I'm gonna delete this one, and first we'll, yep, then let's copy these. Or what we need to do is, okay, let me copy this and create a bunch of lines of code, and then we can just copy this in a couple of places. First is this is going to be ELU, this is ELU, and this is ELU. Then copy this. This is linear. This is SELU, SELU, SELU. Likewise, we have the GELU, GELU, GELU. With the swish activation that goes there, that goes here as well as here. The mish activation that is there, we have the mish, and then we have the relu activation. We type that there, and in addition to that, then finally we come to the sigmoid part. We have the sigmoid, and then we have the soft sign, which looks like this, and then we have the softplus, which is there, and we still need one more line of code, so let's do that. And we have the hard sigmoid, which goes there, and we have the hard sigmoid. So the one that we haven't put in here is the it's the softmax, because it has a different set of softmax. The softmax would require us to update this uh, tf dot reshape x comma 1 comma, this is the length of x, and then we can use that down here. So copy this, paste it here. This is going to be x. This is, let's call the, yeah, this is going to be just softmax, and this is softmax. That will take the value of x. Then for what we need to do is squeeze is equal to tf dot squeeze. This is, we squeeze the value of x1, and the same thing we are going to do for softmax. So that's that, and let's try and add softmax into this. So with the value of softmax, let's copy this, put that there, put softmax, and it should be the x and x1 should be the same. We'll just put that there, and then we have plt dot plot. Sorry, plt dot legend. We need to see the legend and run this. So hopefully we should have a nice plot with all the activations. I think this is the softmax that is. Yep. The reason is because we did not use the x1 there. And hopefully we should see the plot now, and this is a beautiful plot we have with all the activation functions in one plot. The linear activation function is where? So linear, where is the linear? I don't see the linear. Oh well. So it looks like I did overwrite on the linear activation function. So let's put that there. Put a y and then type in linear and run this again. We should now see all of these. Yes, that's the linear activation function. Then we have these other activation and the legend is, so let's put that b box to anchor, and let's put a value of 1 comma 1, and let's run this again and see what we get. Okay, nice. So here we have all the activation functions. We have the linear activation function, and then the other activation functions are within the same range as we see. So these are between 1 and +1. So if we limit the x-axis, sorry, if we limit the y-axis, limit plt.y lim, we simply go from -1 to +1, then we would be able to see much more clearly how these shapes change. And as we can see, these shapes are most of the changes happen in the negative side, where these try to approach 0. These are the gelu, gelu, then swish, mish. These are the elu, selu. I believe this is the soft. Okay, that's the soft plus. We have the soft max that goes this way. Then this is the one that falls rapidly to 0. This should be the tanh h. Sorry. We don't have the tanh here, so let's plot tanh. Miss tanh. Copy and put a tanh. So this is tanh, and let's use the x there. For this again, why don't we copy this here, call this tanh, and call this tanh, and so we should be able to see again a nice plot. So here we have the tanh. Oops, there's a typo. Tanh, just need the h. There's no need of n after this. Okay, so that's the tanh. We can see that the tanh drops rapidly down to 0, whereas the other ones, they approach 0. So not 0, but they fall rapidly towards the -1 sign as compared to the other ones. And if we create the same plot without the limits, we can do that. So let me copy this entire thing, put that here, and we just remove this or comment that line out, and should be able to see another plot, which is this one. So in this case, as we can see, these values do approach. This is -1. These values go much beyond -1. So yeah. So is what I'm finding confusing is why tanh in this case is not going there. So let's change this to maybe -2 and run this again. Okay, yeah. So here we see it now. So that's our tanh. Uh, then we have, this is the selu, elu. Then the soft sign. Where is the soft? I think those are soft sign is this one, softplus. Yep. Okay. So these are the different activation functions, as we can see. That's the hard sigmoid with the sharp angle. That's pretty clear there. I hope in these couple of videos you got some intuition about how the shapes are for different activation functions, how they look like, and how we can use them in TensorFlow for performing these sort of calculations. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in this series in the future videos. Thank you.